Picture this scenario. A pharmaceutical company has developed a new drug aimed at reducing high blood pressure. Now, the company needs to know whether the drug is effective or not. This is a real-life example where hypothesis testing comes into play. Hypothesis testing is a statistical method that helps in making decisions using data. It's a way to test the results of a survey or experiment to see if you have meaningful results. It's kind of like an investigative tool in the statistics toolbox, used to judge the credibility of a claim based on the evidence from data. Output: to conduct a hypothesis test, a scientist will start with an initial claim, known as the null hypothesis. In this case, the null hypothesis might be, the new drug has no effect on high blood pressure. They also consider an alternative hypothesis, which could be, the new drug reduces high blood pressure. The scientist then collects and analyzes data to decide whether there's enough evidence to reject the null hypothesis. If there's a significant amount of evidence against the null hypothesis, they reject it, and the alternative hypothesis is considered to be valid. But how does one decide what constitutes enough evidence to reject the null hypothesis? This is where the concept of a significance level comes in. Often set at 5%, the significance level is the probability of rejecting the null hypothesis when it is true. In other words, it's the scientist's willingness to accept that their decision to reject the null hypothesis could be wrong. To illustrate this, imagine you're a quality control manager at a bottle cap factory. Your machine is set to produce caps with a diameter of 2 centimeters. One day, you take a sample of 50 caps and find the average diameter to be 2.05 centimeters. You might wonder if the machine is off. In this case, your null hypothesis is, the machine is fine, and your alternative hypothesis is, the machine is off. You conduct a hypothesis test and find that the p-value is 0.03. This means there's a 3% chance of obtaining the sample data if the null hypothesis is true. Since this is less than your 5% significance level, you reject the null hypothesis and conclude that the machine needs adjustment. But remember, hypothesis testing isn't about proving anything. It's about weighing evidence and making decisions. Even if a test result leads to the rejection of the null hypothesis, it doesn't prove the alternative hypothesis. It merely provides strong evidence in favor of it. Now, let's see if you've grasped the concepts of hypothesis testing. Here's a short quiz. Question 1. What is the null hypothesis in a test about a new drug's effectiveness? Question 2. What does a p-value of 0.03 mean in the context of a hypothesis test? Question 3. If a hypothesis test leads to the rejection of the null hypothesis, does it prove the alternative hypothesis? Remember, statistics isn't about numbers alone. It's about understanding data and making informed decisions. So keep exploring, keep questioning, and keep analyzing.